Look, what we've done, we've just put a trial in to try and evaluate the effectiveness of the various sources of phosphorus fertiliser. So we're looking at our liquids, our biologicals and our rock phosphates. Now, before I get started, I just want to reinforce that this particular trial wasn't put in to criticise or discredit any particular system. Purely what we're trying to do is validate the systems, let the growers and advisors come out to the paddock, see it for themselves and then see the yield results. So that's why we basically put it in the ground. Now the specific questions that the local growers and advisors wanted some data on were, can rates be reduced when using liquids? Do liquids allow us the opportunity to split P application? Obviously that goes against current protocol where we need to put all our P up front. Also, do rock phosphates release enough P to provide for crop requirements? Now we know our rock phosphates, generally speaking, need high rainfall, acid soils for them to break down. We don't necessarily have those acid soils where I'm from, but we certainly had the rainfall this year. Also, if you're adopting a biological program, how important is it to use a microbe-friendly seed treatment? Some of the biological advocates would discourage the use of fungicide treatments as that's going to nuke the bugs in the soil, therefore it's going to reduce nutrient cycling, therefore that'll reduce that fertiliser actually breaking down and working. But the big question is, which form of P was the most cost effective? So how did we go about it? We had two trial sites, one at Peak Hill and one at Gunningland. The Peak Hill is a more uniform soil or a common soil. For our particular area, it's a red soil like clay, pH of 5.5 on the top and gets neutral at depth. We've got moderate P levels of 25, Colwell, and it's got a fairly normal PBI of around 58. A lot of our soils seem to range between 40 and 70 around Parks, Forbes, Tullamore, etc. Compare that to the Gunningland site. It's a heavy cracking clay. We've got a pH of 7.5 on the top soil and actually gets more alkaline at depth. Now this is near one of the lime quarries at Park, so we've actually also can see a bit of free lime in the top soil as well. So free lime is very commonly known to actually lock up some of the P. At each trial site we had two trials. We had a product trial and a systems trial. The product trial is where we put all the fertiliser, the fertiliser product we used. We just treated all the seed with Raxil, and in the systems trial we actually put on the recommended seed and or foliar treatments for the various systems. Now what we're trying to do there, we're trying to identify or evaluate how important is it to adopt the full system program to compared to applying the fertiliser on its own without adopting the seed treatments and foliars, etc. Rates we used 5 units, 10 units and 20 units of P. The reason we did it at those increments, we want to know, does 5 of liquid outperform 10 of granular, etc. We also put an additional liquid treatment in where half the P was applied at sowing, direct inject at sowing, and half was applied at mid-booting. In 2009 we applied the second treatment at mid-booting. In 2010 we brought it forward and we actually applied the P just after tillering to try and give it a better chance to actually work. And all the plots were actually balanced out with nitrogen. They're the products we used. We've got our high analysis, we used MAP, and then our biological products, we had a pure rock phosphate and we also had a rock phosphate plus 30% DAP. And then we've got our two forms of liquid. We've got a phosphoric acid and a polyphosphate. Probably the key thing to note there is cost per tonne. Our MAP was $950 a tonne. We've got 22% P, it comes out around $4.32 per unit of P. Now we compare that to some of the other products, say rock phosphate plus 30% DAP, it's only $786 a tonne, but it's only got half the amount of P in it, well 8% P in it. It actually comes out at $9.83 per unit of P. So there are big differences in cost per unit of P. So in other words, what that means, if you had a $10,000 fertiliser budget in 2009, I'm still using my 2009 data for that, sorry, that would have given you the option to buy 2,300 units of MAP, 1,500 units of rock phosphate, or only 700 units of liquid. So obviously, if you choose to buy or select a product that's more expensive, you obviously can't buy as much P for that same dollar value. So you really want to be sure that it's going to be more responsive to that form of P. So for example, in South Australia on the calcareous soils, we know they're getting some responses to liquid P. And that's why they're using that. So that's what we're trying to validate with these trials. Or another way of looking at it is break-even yields. So if we were going to put on 20 units of MAP, our break-even yield would have been around that 0.5 tonne to the hectare. If we look at the rock phosphate plus 30% DAP, our break-even yield would have been a bit over 1 tonne to the hectare. And if we do the same for our liquids, it would have been up around 1.5 tonne to the hectare. So there are some really big differences in costs associated with the different products. Now, remember, you want to do these figures each year, you know, because maybe prices will change and etc. So you need to be aware of that. Now, the additional products we used in the systems trial, so the biological system, we put on a seed treatment, which was just a broad spectrum inoculum of compost microbes, and it had some traces as well. We had a foliar treatment, which was just the same broad spectrum inoculant of compost microbes and also trace elements. And then with the liquid system, we put on a zinc seed treatment, a seaweed extract, and we also put on some trace elements as a foliar spray. Now remember, what we're trying to figure out here, do we have to adopt the full system compared to current district practice, which I'm just saying is MAP, to actually get the full benefits? The 2009 seasonal conditions, this is the site at Gunningbland. We started off with really good moisture. We had around 84 millimetres of plant available moisture at sowing. We had great rainfall in June. The crop was going really good at this first third of the season. But as I'm sure you're all aware, we started to run out of puff and we had some fairly major moisture limited yields there. Compare that to the PQ site. We started off with zero moisture. We had a 0% fallow efficiency. We were fortunate enough to have some great rainfall in June. It started to run out, but we were lucky to get some rain post-anthesis to actually help harvest this trial site, because it wasn't looking terribly good. It's quite interesting. These two particular sites had the same effective rainfall. One site relied on stored moisture and one site relied on in-crop rainfall, and they both ended up yielding the same. So the work that James Hunt was talking about earlier and stored moisture and so on, it certainly validates that work. So the results, the two questions we want to know, firstly, was the site responsive to P? And secondly, did the different treatments, different fertilisers respond differently? So how we went about doing that, we did an early vigour score where we got the local growers and agronomists to come along. It was about 10 weeks after sowing, and we just conducted an early vigour assessment. So each grower advisor was given a sheet of paper that just had a plot number on it, and they just went through and gave each plot an early vigour score. So 1 meant terrible, 10 was fantastic, 5 was about average. The reason we did this, we just really wanted to capture that information, I suppose. Could the growers actually see any visual differences, and could they consistently see visual differences? So there's 4 reps. Could they consistently see differences amongst the various fertilisers, as well as just getting them involved with the actual trial? Just so before I put the results up so you can calibrate yourself, that was given an early vigour score of 3, that was a vigour score of 5, and that was given an early vigour score of 8. So the Gunningbland site, this was mainly made up of the local agronomists. This is our various rates of P and the early vigour score. So we can see here that the rock phosphate had a very flat response. The agros couldn't tell the difference between rock phosphate and the nil treatments. We add 30% DAP to the rock phosphate, and we're starting to get a bit of a response. As far as the liquid phosphoric acid and the MAP responded very positively, but the one that actually came out on top was the polyphos. Now, the polyphos just had, there are a few of you who have actually been to the trial site, I know, it just had the most freshest look. That's what a grower ended up summing up. It just had the freshest look to it all. It looked quite impressive. That was the product trial. So the systems trial is when we adopted all their seed treatments and foliar sprays. Again, the rock phosphate had a very flat response. We put 30% DAP with it. We started to get a response. The liquids and MAP all responded very positively. But again, the polyphos just had the slight edge. Now, I'm sorry, I wasn't here for Jim's talk yesterday, but with the error bars, there's the CV and the LSD for you to actually do the calculation, sorry.
What volume did you use with liquids?
To actually, for the direct inject, yeah, 150 litres a hectare. And just some of the growers that are using it, some are using around 80 litres a hectare, some around 150 litres a hectare. We used it at 150 litres a hectare. So the early vigour score, it really is an extension tool, really, from my point of view. but a good way of capturing that data. The tiller counts are a bit more harder number on it. Again, you can see the rock phosphate, it didn't convert to any more tillers. A slight response when 30% DAP was included. But your liquids and MAP all responded positively, and MAP came out actually on top with a 50% increase. The systems trial, again, the same sort of response. The rock phosphate was a very flat response. At 30% DAP, it started to have a slight response, and the liquids and MAP had a positive response, but again, the MAP was actually what came out on top, and that's also a significant difference there. So how to convert to yield? In the gunning blend product trial, it didn't actually convert to increase. There was no statistical difference between it, but in the systems trial there was. Again, you can start to see the trend. The rock phosphate, flat response. At 30% DAP, we started to get a response, and all the liquids and MAP had a positive response. But keep in mind, you know, these yields aren't terribly great that we're actually looking at. I suppose the thing we questioned out of 2009 was this split P application. You can see how it went, you know, it actually went quite well. So this one here is where you put 10 units of P up front at sowing and 10 units of P at around mid-booting. We put it in that first year. And I was a little bit surprised by that. However, basically we had to put 1,000 litres a hectare of water on to actually put that higher rate of P on, of 10 units of P. So, you know, effectively, all the growers were laughing around Parks for obviously, you know, we've effectively given it an irrigation as such, 1,000 litres a hectare. Now, obviously, that's not going to be practical for a grower to actually put on, but that was the labelled rate that we had to actually put it on at. So I spoke to the rep this year, and we've actually put it on at 150 litres a hectare, just so it's going to be a bit more, that's just converting it to water use efficiency, which is just the same as the yield. Now remember, that's the gunning blend site, it's a cracking clay, and we've done a deep ripping trial there this year, and that's a bit of the free lime that's actually coming up. So free lime is quite well known that liquids work reasonably effectively in that sort of country. Now for the more common soil type at Peak Hill, the early vigour score, this was done by 22 growers and 3 agronomists. Again, the growers couldn't tell much of a difference between the rock phosphate and the nil, but the liquids and MAP all performed positively, but they couldn't tell the difference between the two, between the two liquid products and the MAP. They all, no visual differences. The Peak Hill Systems trial, again, the rock phosphate was, they could not tell any differences. The liquids and the MAP all had a positive response, and they couldn't actually tell the difference between the liquids and the MAP. So how did that convert the tillers? Again, the same trend. The rock phosphate, very flat response. We add 30% DAP, we're starting to see an increase. The liquids responded positively, but the one that actually came out on top was MAP went just as good as anything else. The way I'm looking at these graphs is seeing where is MAP with all this. It doesn't matter whether it's MAP or DAP, but MAP is kind of like the bar that we use that the majority of growers are actually testing. So we're wanting to know, are the liquids above that or below that, and same with the rock phosphate. Again, you can see the same sort of response there. The rock phosphate very flat, and the MAP again is coming out on top with tiller counts on the systems trial when we put on all the foliars, etc. Just to also, Jim Laycock mentioned it as well this morning, we did see quite a large difference in maturity. So the nil P was a lot slower, it was in a bit of an armchair compared to the high rates of MAP and liquid. The maturity was quite a lot. I'd support basically exactly what he said. And the liquids and MAP were the same, but even the high rates of rock phosphate, it was the same sort of maturity as the nil P. So now the previous year, 2009, just trying to see if there's any locals in here, I don't know about down here, but we had some really extremely hot conditions during grain fill, and then we ended up getting some cooler weather. So there might have actually been a bit of an advantage for some of the nil treatments and the rock phosphate treatments because they were actually a little bit slower in actually maturing as far as grain fill is concerned. Gross margin for gunning blend. In a drought year, the nil P came out on top. Probably the key point here is you can see the map of 5 units, 10 units and 20 units. It hasn't lost a huge amount of money. We've still actually, we haven't gone backwards with it. We compare that to our liquids and we go backwards a long way on those higher rates. Now the rock phosphates, have actually done reasonably well in the gross margin. However, we can see, this is in a drought affected year as such. So it's purely coming down to cost per unit of P is what we're looking at. And P-Kill is exactly the same sort of trend. So that was 2009, so 2010 data, and I'm really sorry I haven't actually got a huge amount of 2010 data because I'm still sifting through it all and getting results back. But completely different. As far as the seasonal conditions, you can tell there we're above a decile 5 the whole year. We keep getting rainfall. It was a lovely little change. So again, for the gunning blend product trial, the Rock Phosphate was a very flat response from the nil. No response. As far as the liquids and MAP, they all ended up yielding the same. There was no actual significant difference between the actual liquids and MAP. I suppose some things to note there. I was actually expecting a larger response there this year than what we're seeing here. So the nil went quite well, and we got up to around 4.8 tonne to the hectare with 20 units of liquid and MAP. This year, this did get rain affected basically, and we also did actually get some shedding of some shelling of the grain, and it happened basically. So I would wonder if, see how it gets very flat? It gets very flat sort of response. Visually looking at the crop throughout the year, we had quite large differences, and I'm wondering, I can't prove it, but because the maturity was, the higher rates of P was more mature basically, therefore it would have possibly shelled out more than some of the lower rates. That's what I'm wondering. But that's what actually happened. And that's when we actually look at the gross margin. Probably the interesting, so you can see there the 5, 10 and 20 of MAP actually made a return compared to the nil, and the Rock Phosphate this year, obviously it cost you more as well as it wasn't responsive, so therefore it really did actually cost us a fair bit. Compared to, now the liquids, they work just as well, but it's purely just the cost that's making them not as attractive. As far as the benefit cost ratio, the MAP was around $3–4 for every dollar invested at 5, and then you can see there with the 10 of MAP, and the liquids were just far less. Again, it's due to the cost. Combined gross margin, comparing 2009 and 2010, the nil went quite well really. You can see there the 5, 10 and 20 units of MAP, at least they've actually caught up from the drought, and the 20 units of MAP has done well. And when we go to the Rock Phosphates, now we've really lost, we're starting to lose a significant amount of money over the last 2 years. And same with the liquids as well. So as far as a summary of the fertiliser response curve, and sorry I've still got to get off obviously all this year's data to actually finish this off. But the high analysis and granular, they both performed very positive, responded very well. The Rock Phosphate had a very flat response. It basically wasn't responsive, and the addition of biological additives to the Rock Phosphate didn't improve that response curve above the MAP. So in conclusion, we can't control the season, but we can control how much we actually invest in the crop. So each season is unique. 2009 was a drought. However, it started off fantastic. We had good moisture at sowing. We thought it was going to be fantastic. Zero moisture and it was a drought. Now, we couldn't have predicted that. 2010, complete opposite. Didn't stop raining. I actually thought the locusts were going to be our biggest threat, but it turned out that we had a wet harvest and we ended up losing some through shelling. So the truth is we don't know what's going to happen at the end of the season, so it's really important reminder to select a fertiliser that's going to respond effectively, but also is going to have the lowest break-even yield to actually cover that investment. And over the last 2 years, that has been the high analysis granular throughout this trial.
Have you just chosen 2 different sites, 2009 and 10, or you're repeating it back over the same plot?
Yeah, so 2009, 2010, both exactly the same trial sites. Each treatment is placed over exactly the same plot. So we're trying to get that cumulative effect with it. As far as this year, moving forward to this year, we probably won't do P-Kill site. It's actually sort of an unfunded trial, so we probably won't be doing it at P-Kill and just concentrate more around that Forbes area, the gunning blend site to do it. I think it's going to be, I'm really interested for this year because this is our first big year that we've had for a long time, so you'd expect it to be pretty responsive this year. And it'll be going into canola.
Do you have any soil testing with Col McMaster at all?
Yeah, we have. So on the PQ side, I had a low Col LP of 15, and on the gunning blend side, I had a Col LP of 25. We've also had some total Ps done. Sire, I've done some total Ps for us, and it was around 250 total P. And you know, and obviously you've got your Cols for measuring 15 and 25. Yeah.
I was just wondering, it seems like you got a better response on the nil than you did on the rock phosphate.
Yeah, if you actually then have a look at the LSD, I should have had the error bars on there rather than just actually putting the 5% LSD figure. You'll see that there's no statistical difference between the nil and the rock phosphate.
If you're doing the same plots year after year, you're taking the Col LPs at the beginning of each year?
We took the Col LPs at the beginning of the first year, but no, we haven't, because we don't have the funds to actually do that basically. But we'd love to. But what probably the aim is, I'm not quite sure how long we'll run the trial for. It's going to largely be determined on what the local growers and advisors, you know, what sort of information they're sort of after. At the end of the trial, so we'll probably go again this year, and at the end of it what we'd like to do is actually just put no fertiliser out over those treatments to have a look at the residual impact, if that makes sense.
I know that Mark Conyers is interested in the rate of rundown of phosphorus in low phosphate systems. So that would be an interesting sort of thing to be looking at as well.
Yeah, yeah. It'd be nice to do some soil testing on each plot.
How do you sample soils
at home?
Funding like that, and hope that you can get funding over.
Yeah, that's how we've pretty much run the whole trial so far, to be honest.
Sounds like you might have some there, Helen.
Yeah, that'd be great. But actually, no, it's a valid point. What we should do is actually take the samples. You know, you've got a valid point. We should just take the samples and hope that the rest comes later. So for this year, yeah, it's a good point. Yeah.
If you add more excess nitrogen, I suppose, or over the top nitrogen, you get better response from the phosphate.
Yeah, probably. This year, being the kind of season that it was, it probably would have been good to actually put a top dressing down of N. And certainly this coming year we'll be doing that. Yep.
Testing the actual grain itself, I suppose, phosphate is in there as well.
Yeah, we have actually done what Helen suggested. We've actually kept all the grain quality over the last 2 years, all the grain samples, and we have actually been able to access some money to actually get the grain testing done on that. Because I suppose the practical purpose that we're doing it really is because people are questioning, are we actually putting too much phosphorus on? So how much are we actually removing as such? Yeah. And how much of an impact does it have from a good season to a bad season as far as the P that goes into the grain?